So percentage of transfer and saturation. This is a number that most people aren't going to hear a whole lot about. You're not going to look at this number when you go to your doctor. This is the thing when you look at your lab work on your portal that you're going to spend a lot of time looking at. But I want you to know this is an extremely important number. This is the percentage of iron that's going to be bound to transferring proteins or carrier proteins through your body. Why is this important? Is because there is nothing more important in your life than oxygen. I don't care what you say. I don't care if you think your dog is the most important thing, your wife's the most important thing, your kids are the most important thing. Oxygen is the most important thing in your lifetime. You can't live without it for more than 8 minutes, okay? If you have an anemia, that is going to be the single biggest factor on your health, is your body's ability to handle oxygen. You get the idea. When you go to the doctor and he said, well, you're a little anemic. I'm just telling you that's a ridiculous thing to hear, all right? So this percentage of transfer and saturation is going to be a very important and very sensitive marker to tell, do you have an iron deficiency anemia? Your red blood cells need iron in order to carry oxygen. So if the percentage of our iron is all bound up with a protein, some of it becomes unusable, and then we get an iron deficiency anemia. So we can have enough iron, but if too much of it is bound to a protein, it's not usable by the body. So this percentage is a very sensitive number. It's a very good number to determine, does somebody have an iron deficiency anemia? It should not be overlooked when determining somebody's red blood cell health and their ability to carry oxygen in their blood. This is so important. Your brain is 2 to 3% of your body weight, but it consumes about 30% of your oxygen. It's like a 1972 Cadillac Coupe de Ville, right? It gets like 2 blocks to a gallon. It's horribly inefficient. This small percentage of your body, per weight, is using a very, very high percent of your oxygen. So if you have an anemia, understand it's going to affect your brain health, okay? It's not just going to affect your energy in your lungs, make you short of breath, lower your energy. Yes, it is, but it's going to affect the health of your brain. You need to make sure your red blood cell health is as perfect as possible. So when you're going to get these things looked at, there's all kinds of other markers that need to be addressed. Your hematocrit, your mean corpuscle volume, your mean corpuscle hemoglobin concentration. There's all kinds of different markers that go into looking at your red blood cell health, but this is a very sensitive marker to determine, do you have an iron deficiency anemia? This percentage of transfer and saturation can go up or down based on the amount of iron you're consuming in your diet, but it also can be impacted by the amount of binding proteins for the iron in your body. It's just very important to understand you've got to get that ideal. So an iron overload, if you're taking too much iron, this is impactful, right? It's gonna change the percentage that's available, because it's gonna change your body's ability, and it's gonna change how your body produces these proteins to bind to that iron. So the amount of iron you're consuming is going to change that percentage up or down. You don't want an iron overload. You don't want to take too much iron. Number one, too much iron tends to give you constipation. But number two, and a more important factor for your overall health, if we have too much iron in the body, that's going to affect this percentage. If we have too much iron in the body, iron, just like if I put iron outside in the rain, it's going to rust, okay? It's going to do something called oxidize. Well, iron in your body is going to oxidize as well. That oxidation creates a lot of inflammation. It creates something called oxidative stress, or something you probably heard about called free radical production. If we have free radical production, that impacts even the health of our DNA. So we don't want an iron overload. At the same time, we don't want too little iron in our body, because we become anemic. Just what we've been talking about is if we have too little iron, we can't bind oxygen to our red blood cells. So we need a right amount of iron. There are good types of iron, there are bad types of iron. You can look this up. There's something called inferior iron and superior iron, or another word for the inferior is rock iron, superior iron, another word for that is heme iron. Those of you who are vegan or vegetarian, not going to get much heme iron. That's a superior iron, and that heme iron is iron that has been produced or processed essentially by an animal's body. So it is more common to be anemic, iron deficiency anemia, if you're a vegan or a vegetarian, because you're not getting that iron. I'm not commenting on your choices. I'm just letting you know you've got to watch these iron levels, because if you're not eating red meat, it's a good source of heme iron. So it could be lower. Anyway, I kind of got off this percentage for iron saturation, but it is a very specific marker for iron deficiency anemia. It also is a marker to look at if somebody has a genetic condition called hemochromatosis. There are other diseases that can be impacted by it. And all of your red blood cell markers, the quantity and quality of your red blood cells, need to be considered also when determining if somebody has an anemia. But this is an important one. If this number is too high or too low, your iron levels could be fine and you could still have an iron deficiency anemia.